Assalamu alaikum students, welcome to the Phys Maths Concepts. This is Shamsa Jabeen and we are solving Cambridge IGCSE Physics Paper 6 Alternative to the Practical May June 2025 with the code 062562. In this video we will solve question number 2 of this paper. Let's read it. A student investigates a light dependent resistor LDR. A student suggests a series circuit. Okay, we have a series circuit consisting of power supply. You can see the power supply, the switch and the resistor and a LDR that is here. Okay, so what we have, part A, wait, I will change the color, red. Okay, so what we need to show, the part of the LDR of the to figure 2.1 shows part of the circuit that the circuit student assembles. Complete the circuit. What we need to do, complete the circuit by adding the correct symbol of LDR between Y and Z. So if I will make some space to clear it, we have this one Y and Z, and we need to put a LDR circuit LDR symbol. So we all know that this is the symbol of LDR, light dependent resistor. So just draw it on the circuit. So I think I should use the blue color. Okay, so this and this, right? And we have the radiation signs. Okay, now come to the question number B. A student closes the switch, connects the voltmeter across 470 ohm resistor, record the reading on the voltmeter and open the switch. So what he did, he first closed the switch. This is our switch, right? This is our switch, and he closed the switch, means it is connected, right? And then he connect a voltmeter across the 270 ohm meters. So basically this is 270 ohm resistor and we need to connect the voltmeter, right? And then we all know that voltmeter always connected in parallel to the circuit, right? And what about the ammeter? It must be in series. Okay, record the reading and then switch off. So what we need to do, what they want from us, draw a voltmeter connected to measure the potential difference across 470 ohm resistor. So we need to draw it. So how we will connect it? It must be in series, it must be parallel. So you can write V, this one. Okay, I think I should clean first and then I will draw it. Okay, so this is our, okay, and for this one we have a voltmeter V and it is connected in series, in parallel. Okay, now move to the next part. The voltmeter reading is shown in the figure. Okay, so this is voltmeter reading. Record the voltmeter readings VXY. So students, you can see this one is whole is 1, right? So how many lines we covered? 5, 6, 7, 8. 8. So it means 0.8 volt. Then the current in the circuit was calculated VXY divided by R with this formula. Okay, formula is given. R is given. We calculated the above one. Just substitute the value and get the answer. Because I am sure they are asking you to find current. Yes, they are asking us for finding the current. I is equals to VXY is divided by R. I am not again writing the formula, just substituting the value. 0.8 divided by 470 and it will give you the answer 0.001703. right? So it comes out 1.7 into 10 raised to the power minus 3 amps, right? Okay. Now move to the B part, D part. The student closes the switch and connects the voltmeter with point Y and Z. Again he closed the switch, record the voltmeter reading VYZ. This time he recorded the reading VYZ, this one. Students, the reading of the this one, the reading of the LDR, this VYZ, right? Okay, and it is given 2.2 volts. Calculate RB of the LDR in bright light using the equation. So RB we need to find out, and the equation again, the formula is given. So I am just substituting the values for finding the answer. In this case, the voltage is given 2.2 volts. So students, what do you think? What about the current? Which current we need to use? We will use the above current that we calculated for the for the resistor, this one, 470 volts, this one. Why we are using the same current? Because our circuit is in series, right? The resistor and LDR are in series with each other, so the value of the current is same. Just substitute the value 1.7 into 10 raised to the power minus 3. You will get the answer for the D part, and it comes out to be 1294 ohms, right? I am just rounding off. You can check it. You will get the answer 1294.117. Okay. Is it clear? Now let's start with the E part. The student covers the LDR with the piece of card and repeat the procedure. We get the different values of VXY and VYZ. Calculate the RD. RD means resistance of the LDR in dark, and it is calculated with this formula, right? Formula is given. Just substitute the values and we will get the answer. So RD equals to 470 multiplied by 2.9 divided by 0.15, and it comes out to be 9086 ohms, right? Okay. Again, read the next part. Student removes the card from the top of the LDR and slowly lifts it vertically upward, right? Means student is removing the card from the top of the LDR. In the previous case, okay, I will again repeat. In the first case, we have light, right? In the second case, we have dark, means the LDR is covered with the piece of a card, and we get this calculation, right? In this case, we have student is basically removing the card. So it is a situation that first we have a darker area, and then with the time it will be moved to the lighter one. Okay, so this case is the second part. Okay, now let's read it. Until the card moves 30 centimeters above the LDR, the student observes and records the reading of the voltmeter across LDR VYZ on the card, and the result is in table 2.1. Describe how the potential difference across LDR VYZ changes as the distance from the card and the LDR increases. So basically students, you can see that in this part the distance is increasing as the card is moving away, right? And the potential difference is decreasing. But still we have two portions. Up to 90 it is decreasing, but from 92 onward it is constant. This portion is constant and this is decreasing, right? So we will explain this. Initially potential difference decreases. So why it is 2 marks? Because we need to give both the reasons separately and clearly. Initially potential difference reduces as distance increases up to 20 centimeters. Okay, and the second point is the VYZ after, we can say after 20 centimeter, or no, I think we should say from 20 centimeters VYZ is constant, right? Okay, now move to the last part of this question, F. When LDR is covered with card, the current in the circuit changes. Okay, they are talking about the current in the circuit. Keep it in mind, it is not the current of a resistor or the current of the LDR. They are talking about the current for the whole one. Student use the student's result from B, D and I. These three parts will be used to show the change in current affects the value of the total potential difference. Okay, again they are discussing the total potential difference Vxy and Vyz. So how the change in current will affect both of them, right? So the first thing is, the best thing is, we will calculate the current value, sorry, the voltage value, potential difference for both of them separately. So I am writing here in dark and in light, right? For your like to explain you, I am writing it very briefly. Okay, detailed one. Okay, I think we will in dark and in light, and we will see Vxy. We will check the value of Vxy, what is the Vxy and what is Vyz. Similarly for the light one, Vyz. Okay, so in dark, I think this one is, okay, first one is bright one, so I will write the bright one, 2.2, this value for Vyz, and Vxy is 0.8 and 2.2, so it is 0.8 and 2.2, right? And for the second one is, we have 0. This value will be used 0.15 and 2.9, 0.15 and 2.9. Okay, so the total voltage V total equals to Vxy plus Vyz. So it is 0.15 plus 2.9, it comes out to be 3.05, and V total is in dark, right? D. Similarly, if I find out the V total, again the formula is same, Vxy plus Vyz. Just substitute the value 0.8 plus 2.2. It will give you the answer V total in light. It will give the answer 3 volts, and it will give you the answer 0.05 volts. Okay, students, if you observe it, these two potential difference values is nearly equal, right? And we can say potential difference is nearly equal in bright and dark. Or we can say it is almost constant or nearly equal. This is I think same thing, and you just write the values here, right? Also mention the values, and you get the reason. You will get the 2 marks. Okay, thank you students. Allah Hafiz. Bye bye.